that point and that point, because this is going to be our D, and this point down here is going to be our C. So you see, it's everything just sideways. Same picture, just turned, rotated, basically. So how do we figure out where these two hit each other? Set them equal to each other, right? Set the functions equal to each other. In other words, set this equal to this, right? That will give us our intersection. So I'm going to set 1/2 y squared minus 3 equal to y plus 1. Notice that the equation that I'm using here has y's in it, so my answers are going to be y values, which is what I want because my type 2 region should have constants for y's. This is a quadratic equation, so if I were going to solve that, I would just clear out the fractions first, multiply everything by 2. And then I get everything to one side. What, minus 8? And then I'd hope it factors. And if it didn't, I'd use a quadratic formula. But it should factor. Minus 4 plus 2 are the factors. Y minus 4, y plus 2. Two solutions, 4 and negative 2. That's reassuring because I should have two y values where they hit each other over there. So, feeling good. C is going to be the one below, so negative 2, and D is going to be 4. Now it's just write the integral. That's all it is now. All right, here we go. Double integral. What are the limits on the first integral? Negative 2 to 4. And then second integral, what's the limits? 1/2 y squared minus 3 up to y plus 1. The integrand, xy d x dy. There we go. Would you like me to work this one, or do you want me to just say dot, dot, dot? Dot, dot, dot? Okay. On the homework videos that I did for this section, I worked through the first couple, so you can see all the little details of plugging in. And okay. What do you all think? I'm not quite sure how to gauge what I'm getting from you all right now. Are y'all tired? Y'all ready for summer or what? Remember, we're like halfway through the semester. It's not like Christmas break, or it's not like Thanksgiving where you come back from Thanksgiving, there's like a week or two of school and then it's all over. No, we still got a long way to go. So deep breaths. There was the region. I'll do this one quickly. It's kind of an interesting solid. There it is. Find the volume of the tetrahedron bounded by this, 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 and this. And so what's a tetrahedron? What's tetra? 4? A pyramid is an example of a tetrahedron, kind of. I did give you a tetrahedron on the first exam. Exactly. Yeah, so look, the reason I didn't say pyramid was because I think the standard pyramid that we think of, yeah, has like, you know, one top and then 4 corners on the base. Tetrahedron, we're going to have 4-sided. It's going to be 4 surfaces, four faces. This would have 5, wouldn't it? Okay. So I have a tetrahedron that is created by, that is formed or bounded by this, which if we graph this, this is a what? A plane in 3-dimensional space. What is this? A line in 2-dimensional space, but in 3-dimensional space, it's a what? It's a plane. X equals 0, what's that geometrically? A line in 2-dimensional space and the YZ plane in 3-dimensional space. Remember one of our first conversations we had, like, what does x equals 0 look like in R1? What does it look like in R2? What does it look like in R3? Okay, so understand what the question is asking here is, you have 1 plane, 2 planes, 3 planes, 4 planes in 3-dimensional space. They enclose some solid. What's its volume? Now, if we want to say we're only looking in 2-dimensional space, I agree, that is a line, and, well, Z, hold on, we're in 2D, so Z wouldn't count, would it? So how in the hell are we going to draw this? So let's agree with something here. Let's try and draw this. I don't think we've ever tried to draw a plane the way I'm about to do it. Let me just try and draw. There's my X, my Y, my Z. All right, let me try and find if this plane hits the x-axis. Does this plane hit the x-axis? If so, where? So if you're on the x-axis, what's your y-coordinate? What's your z-coordinate? So if y and z are both 0, what's x? 2. So do you agree I would be out here 2? That point lives on the plane? Agreed? What about the y-axis? Does it hit the y-axis? At y is 1. So this time, if you're on the y-axis, x is 0 and z is 0. So you would get just 2y equals 2, so y would be 1. That point lives on the plane. And what about the z-axis? Where does it hit the z-axis? Up at 2? So what I can tell you right now is that this plane passes through all 3 of those points. So if I connect them with lines, that triangle lives on that plane, doesn't it? But it still extends in every direction forever. All right. What does x equals 0 look like? If I graphed it? That's the YZ plane. Isn't that this wall right here? So it's the entire wall, isn't it? Doesn't that kind of like close off the back section of this tetrahedron we're creating? Y'all see that? That's like a back wall of that tetrahedron. What does z equals 0 create? XY plane, which is the floor, isn't it? So everything down here. And then, one more thing. There's one more plane that we need to look at. X equals 2y. So that looks like a plane, right? Could I draw it on here? Can you draw me the plane x equals 2y? Can you tell me one point for sure that it goes through? The origin, right? 0, 0, 0, 0, 0 lives on that plane, doesn't it? If x and y are both 0. So let's see what color I've got left here. I know this point lives on the plane. What other point lives on this plane? Give me something, again, let's draw something that's on the xy plane. So let's let z be 0. Give me another solution to that. X is 2, and y is 1, right? X is 2, 1, 2. Y is 1, I think somewhere around here, right? Do y'all agree? Do y'all see that? 1/2 and 1 would have worked. I'm sorry. No. 1 and 1/2 would have worked. Right? 1 and 1/2? That would have been 1 and 1/2. What I'm trying to get at is that this plane, because z is not in here, goes straight up and straight down. So it looks like, it looks like this. It's got a certain tilt to it because of this equation. In fact, if we draw this and connect these on the ground, right, that's the line that it hits the xy plane in. So I don't want to draw this plane coming out, okay, because I think that's going to cause a problem if I try and draw it out. Imagine that this comes up through our tetrahedron. Do you see the double integral? Do y'all see it? Remember, the double integral gives us the volume underneath a surface above some region. Do you see the region in which we would want to integrate over? Do you see it in there? Okay, let me ask you something. Do you see the surface on top? I need to go get the, what do you call it? How do you say that? Defibrillator? Y'all okay? I'm asking a yes or no question. Do you see the surface? If you don't, then you need to just tell me and I'll try and show you where the surface is. Look, we have a surface on top, and on the bottom we have some domain that we're trying to go straight down in there and get that volume underneath, right? That's what we're trying to do. Okay, do you have a top surface? Okay, where? What is it?
The red triangle.
The red triangle. The plane, right? This right here. That right there creates a top surface, doesn't it? Doesn't it? And if I can just find the volume below it, then I can answer this question, but it's the thing on the bottom is what we have to look at a little more closely. So can you write this as a function of x and y? Yes. As a function of x and y, this is 2 minus x minus 2y, right? If I solve that for z. So that, to me, is going to be the upper surface. I'm going to be trying to find the volume underneath it. When I look down to the ground, though, go straight down from here, do you see the domain that I need to work with? Do y'all see it? Yes? Okay, thank you. Where is it?
The black triangle.
The black triangle?
Between the blue line and...
Right in here. Just this in here. Okay? Just that. It's difficult to see this because I'm trying to draw 3 dimensions on 2-dimensional sheet. Look, if this blue wasn't here, we would have a tetrahedron that would have this plane, the xz plane as a wall, the back would be a wall, and the floor would be a wall, and that would be a tetrahedron, right? But there's one additional thing. We're coming through and we're taking that and we're saying we're slicing it right through, and we're cutting through. See, it's impossible for me to really be able to show you where it cuts through, but it does cut through, and it creates that tetrahedron. I don't know if that helped. Okay? Now, it all makes sense now. That helped a lot? See, that's why I have this. This, whoa, shit. Figure out where I am here. Okay, there's the plane, right? We all agree this is the plane? Well, I didn't show much here, sorry. I thought I was going to show more detail. There you go. All right, so that's it right there. Do you see where that plane came through and sliced that thing right there? That's what I was trying to show in here, is that slice through there. All right, back to business. That's why I'm asking y'all questions. That's why I appreciate answers, because I probably wouldn't have drawn that slice unless y'all showed some resistance. But when I ask and no one says anything, I'm just assuming you're getting it, I guess. I don't know. Or you don't care enough to tell me you're not. All right. Let's draw the domain on the ground, now that I've erased that beautiful picture. X and Y. I already know my surface, right? I already know f of xy was 2 minus x minus 2y. What does it look like on the ground, though? Maybe I shouldn't have erased it, huh? We had this point, it came over, but then I came through and I cut through that way, didn't I? And the region I was talking about was this one in here. Remember, this is the y-axis, this is the x-axis. So can you label at least one point that you know for sure? 0, 0 is here. And 0, 1. We all agree with that? That corresponds to this one and this one. The other point is where these two intersect each other, right? Which is where what intersect each other? This plane, where that plane hit this plane, right? That's what you need to know. Where do those hit each other? So how can you determine where those hit each other? Well, where they hit each other, they're both on the ground, right? XY plane. So when they hit each other, z is 0. So I'm first going to let z be 0. That way I'm on the ground. And I'm going to rewrite, let's see, the first equation is this. The second equation is this one with z being 0 is x plus 2y equals 2, right? If z is 0, that's what the plane is, and that's what that plane is. Two equations, two unknowns. I see a simple way of doing this, right? If this is 2y, plug it in there, or if this is x, plug that 2y. Either way. I'll just take this one, I'll replace x with 2y. So 2y plus 2y equals 2, 4y equals 2, y equals 1/2. If y is 1/2, what's x? Which implies x is 1. So that's where they hit each other, at the point 1, 1/2. So that corresponds to this point right here. 1, 1/2. And we all agree that that's my D? Yeah? Questions? What am I going to ask myself next?